All right, more decoding today. I'm actually becoming like a better streamer, getting my audio right and shit. Anyway, let us get this, and let me just run the code real quick, just see if everything's okay. Okay, so last time I got all this working. And just to prove that this is working, right here you can see that this is our many move.bin. This is what we're decoding, and it's over here. I can do a nasm on many move dot, or I can basically say this and output this to a file called um yeah, I put this to a file called output.asm. Then we run nasm on this, and then I want a bin file, and I want output.asm, and then I'm gonna see output.bin. Then I can do a compare. I think it's a comp like that. Output.bin to many move dot bin question mark. Yeah, so you can see there's nothing. If I do many red, it's gonna show me a bunch of changes right there. If they differ, I think this yeah. However, if I just do this for many move, there are no changes. And just to make sure I did that correctly. um, what am I doing? Oh, right. So I do NAS. Sorry, do 86 exe. Take this or not pipe it, but redirect it to output.nasm. And we have this. We'll do nasm minus f bin output.bin. Oh, select minus O. ls. Perfect. Now I can say compare output.bin to many move without bin, and there should be nothing. If I do output.bin versus like move.bin, it's gonna be problems, as you can see. And if I do that to many reg.bin, there's still gonna be problems. So yeah. Anyways, that basically explains that this works for now. Output.bin. Oops. Where ls? Okay, perfect. Now what we're going to be doing is it's taking surprisingly long to do that. So weird. Okay. Now what we're going to be doing is working on a little thing. First, let me see if the stream is not. Damn, it's so slow. Okay. Yeah, that's cool. Anyways, so now we're going to be doing, what is it? I need to bring that file. I forgot where it is. 6 job instructions. It's page 166. Okay, so now what we're actually doing is we're doing sub, add, just this, add, sub, and com, if I can find it. I guess we're not doing com. That's awesome. Where's com? Right here. We're only going to be doing these three. We're not doing this ASCII adjust or whatever. I don't even know what this is. So we're only going to be doing these three, and they should be quite simple. And there's also a bunch of conditional jump instructions, which are also very simple because it's always 2 bytes, and they always have just some opcode and then some 8-bit whatever IP. I don't even know what's IPINC. I think it's some. I don't even know. Anyways, so it should be pretty easy. What I'm gonna do first is I'm gonna go to Computer Enhanced GitHub. And I'm gonna get the little file from there. So our listing is gonna be, it's this probably right here. So this is gonna be our listing. This is what we're gonna be working on. I heard there's also some challenge homework, which is way too difficult, so I'm just not even gonna try doing it. To be honest, it's like a full-on, yeah, it's completionist decode, and it's literally impossible to be honest. So I'm not even trying to do that. Okay, I'm just gonna download this real quick. Let's put this in downloads, and let's just do add stuff dot in. See. Okay. Now if I go back to this, I can kind of oh yeah. Okay, I can CD back one, CD back another, CD downloads. LS. That's gonna be a lot actually. Shoot. Move. Is there a move like this? Let's move like this. Or should I copy it? Can I move stuff? Add. Yeah. To. Uh. No. Desktop. Oh, there we go. And then 8086 decoder. Okay. Sorry, what am I doing? CD to 8086. There we go, we have it here. Let's just cat it out just to see what's up. I don't think it's actually gonna work. Oh, it won't work, right? Can I do like \T with cat? What just happened? Uh-huh. That was interesting. And what's going on? Clear. Show all no. Okay. Anyways, I don't think it really matters. Let's just do. Okay, cool. So now we're doing this. I actually want to see Let's add, okay, so let's change this. Add sub com G and Z dot fit. Let's see how our thing performs. Actually, I'm just gonna write it. G plus plus minus G minus or 8086.cpp minus O minus G 8086 dot. Okay, so this doesn't work. I don't think it does. Yeah, oh, it's because it's ads. These are a bunch of ads and subs and comps and jumps. So there is no, the original stuff is just missing. This is why it doesn't work. However, this stuff works really well. It works very, very well. That's awesome. You can see right here that most of it actually kind of works off the bat. I mean, not all of it. So immediates don't work, but bx bp plus 0. Does that work? What is that? 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, that doesn't work. Okay. Well, some of it works. Okay, I guess we can start writing this code. Okay, we need to we need to refactor in a major way because this code is really bad. And I'm not sure how to do that. Let's just do that. Okay, first let's get some opcodes in here. 1, 2, 3. So now we have, if I look at it correctly, we have, let's just start off with add. Right here. So we have 3 opcodes for add. Immediate to accumulator, immediate to register, memory, and stuff. Okay, so 0, 0, 0, 0, 0. Okay, 3 6 zeros. 0B 1 2 3 4 5 6. This is also originally 6 zeros. 1 2 3 4 5 6. Exactly. Okay. Then we have what the? We have what's going on? Okay, there we go. So now we have 1. Okay, it's just the 1. Oops. I don't know what's happening. Can I get this to work? Okay. Then we have, can't deal with this. 000 0 001. You know what? I'm not even gonna do this on the screen. I have another monitor. Sorry, you guys are not gonna be able to see it. But I don't care. Yeah, I'm just gonna keep it the other monitor because it is annoying. Okay, let's start off with that. So now we have this. The registers are all the same. Opcode, direction word, quad red, RM, notice, PyDisk. No data, high data. For this is gonna be an int. It's gonna be sign. And we're gonna keep this zero question mark? I don't know. Anyways, this stuff we don't really care about. Try fix this is just helper function, decode instruction. Okay. Okay. Or will we care? Register memory to register. Okay. Coded.opcode. See. If that's the case, then we have decoded.sign equals extract trace terabyte. Wait, how does this have anything to do with move instruction? The only move instruction which I did was immediate to register, which had 4, right? So I need to somehow do this for add, but in this I have the full opcode. Okay, that's a little annoying, I guess. I mean, if I was to write proper code, I would kind of enclose this in some sort of, well, I don't even know what I'd enclose it in, but like a data routine where I'd be like, okay, if you have this kind of immediate to accumulator, you want to start doing data, but we move fast and break things. So here's what we're gonna do. We're just gonna say 7 to, I think, just the regular opcode value. So this is gonna be, let's see, 7 to 2. If 7 to 2 equals uh 7 to 2 equals 0, 1, 2, wait, it's just 3, 2, okay. If it equals this, then that's your opcode. And then you're gonna start extracting bits. 3, 3 is not gonna be word size. It's going to be, here's what we're gonna do. exactly where the direction bit is, that's 1, 1. Okay. That's 1, 1, right? So like 1, it's 1. And are we doing direction or are we doing... Well, we need to accumulator is always 0, so it doesn't really matter, I guess. Okay, that works. Sorry, not direction decoded. Now we can have... Now we can move our byte index. Yeah, yes, this can actually be here. Then low data is 70, perfect. If there's a word size, then okay, this is perfect. This works perfectly. Technically, what I can do is I can wrap this whole thing in some sort of routine, data, extract data, or something like that. But I mean, do I? I guess I'll do it. You know what? Just for the sake of having clean code, like Casey Iratori would love to say, I'm gonna do it. I'm just gonna say, how am I gonna do this? Here's what I'm gonna do. I'm gonna take a decoded thing. So, okay, this is what's my thing is gonna be. My function is just not gonna return anything. It's just gonna change decoded, right? So, okay, here's what I want. I want to void uh, get data or decode data. It's gonna take a instruction. So it's gonna be instruction and decoded, and that's all it's gonna be. It's gonna what is it? It's gonna do this, and I'm just gonna take all this code, and I'm gonna copy this over here. Curby buffer. Oh yeah, I need to pass the buffer and everything. Okay, well, let's I guess we can do that. This is I don't know if this is the best, but I mean, it feels clean. I don't think we need the byte index, do we? Or maybe we do. I'm just gonna pick byte index. Curbyte. Actually, no, we just need curbyte. Sorry, we don't even. Wait, we don't even need this buffer. I mean, we just need current byte, which is an unsigned char. Can you take an unsigned char reference per byte? Oh, well, we do need the buffer. Oops. So I guess it doesn't really matter. Sorry, I'm stupid. Unsigned. Okay. So what we can do is we can just kind of say, yeah, screw all this stuff. Yeah, screw this. We can say decode data, pass in decoded, pass in the buffer, pass in our byte index. Okay. I guess that's cool. Guess that kind of works. Whatever. Let's just see. So now we have decoding additional data. I don't even know if this is like doing anything. Let's check. Okay, there's some ads. I don't know why there's move instructions. I don't remember there being move instructions. Let me just copy this link and put this on the other thing so I can kind of see it. Are there any move instructions? Okay, there's not. It's just hallucinating. We can figure that out later. Okay, for now, we have add bx to bx plus si, which is correct. Add bx to bp, which is correct. Add si to ax, which insert of data. So this is moving an immediate to a register. Or sorry, not moving. It's adding an immediate to a register, which is doing it wrong. Which it's doing in a wrong way. So let's figure that out. Okay, so now when we have this little, so what we're trying to handle is this, this one. I'm just gonna label these things. Register slash memory. Add immediate accumulator. Reg slash memory for the register item. I think I can do this. Oh, you might not. Let me just write this all down, just for documentation's sake. So this is gonna be, this is just a regular move instruction. So this is gonna be register move memory register 1011 is move immediate to register. Move immediate to register slash memory. Okay. So now we have this. We're trying to figure out this one, 100,000. Adding an immediate to a register slash memory. So we already technically have that kind of thing set up. We just don't have it working yet. So let's see. Decoder to opcode 72. Okay. So let me look at the add instruction. The add instruction has display dispatch data. It looks the same to me. Now we have a sign operation. We have the word size. We're getting mod. We're getting reg. We're getting rm. Fine. Then we have this decode additional thing. I think this should all work. If decoder opcode and decoder word size. Okay, so I guess this is what we need to do. Outs of decoder opcode is 1,000 or 100,000, sorry. And then we can just say data equals 1, this is this. We get 2 more data, push it back, print. I mean, it seems like it should work. Don't know if this works. Let me see. Add VS, okay. Add AX. I think add AX is 33538. That is not right. This is completely screwed up. What the heck? Is that not parse instruction? Add immediate to register slash memory. That's a 100,000th opcode, which is what we're trying to decode here. Okay. So first, let me see if I have it. So I have 100,000. That's right. Decode instruction. Okay. Send force this, which it's not. 00001, which it ain't. Else we go here. We just get the opcode. If it's 100,000, we get the sign. If not, we get the direction. And we get the word size. Then we increase it, we get mod res and rm. Then we return. Get instructions. Okay, perfect. Now we switch based on the mod field. Is that not what we have to do for registers? I'm pretty sure it's the exact same. I'm pretty sure it's the exact same. So I mean, I'm pretty sure it's the exact same. Like it has to be. So now we have this placement, whatever. Nobody cares. If the opcode is this, which is what we were targeting, so this is the immediate to register slash memory for move instruction 110001. Yeah, okay. And that's the same thing over here. So else if it's this, I guess it's or. A second, just to make it clear, just do that. I don't know why I did that. Anyways, decode additional. I plus 2 because I is not paid. I is not paid from what? Ah, right. Right. Yeah, that's true. Okay. Decode additional. If there's a displacement, he gets it, puts it in those little high disk, low disk thingies. I mean, this should work. I don't see a problem. I'm gonna try this once more. I think I don't know, maybe there's some minor mistake. But if there's not, I think we're gonna have to go to the debugger. Add AX to 33538. I mean, that doesn't make any sense. Okay, this is debugger time. Desktop 8086. Okay, let's do on GDB excellent. So shell clear. Break at print instructions. Continue or run. Very nice. It's 16. Okay, so BP, this works. Now we're going to the next one. Okay, so this is going to be our add SI to 2. This is what it's supposed to be. Okay. It's 100,000. That's correct. Right? That seems right. Yep, that's correct. Fine. Next. Next. TMP.mod should be 0 probably? No. Huh. It's 1 1. How the heck is it 1 1? I thought mod. Oh, it is correct. Okay. Let me just go to the thing again. Mod 1 1 means it's register mode, no displacement. How is that possible? Then my mod calculations are wrong. Because this is definitely not supposed to be register mode. It's supposed to be immediate to register. Okay, so temp.mod is being calculated incorrectly. So this is something to do with decode instruction, not here. Let's see, decode instruction, send for. So confused. What? 7 6. What the? How? How is my mod 11 or 1 1? I think, okay, this 3358. Let me just search this up. Actually, that doesn't even make any sense. It's supposed to be 2. And even the register is wrong. What I can think of is it's already wrong here, so it's the register itself is wrong. Okay. Huh. One. What? Wait, I don't even care about Reg. What the heck? Reg is useless. Okay, this is still. But why is it printing Reg? What the? Ah, because things loaded instead. Ah, this makes no sense. Kill me. How does this make any sense? How did this even work previously? Immediate register. I mean, it's virtually the same. How is there a problem here? It's supposed to go here, but it's not. It's going here and taking temporal range, which is 0, and converting a 0 to 1. Wait, now that I think about it. Oh, yeah, okay. Reg, it's just 0, 0, 0. Okay. I don't know. This should work. There's something else wrong going on here, which I don't get. Let me stop playing the same song. But let me hear it once more. How do you do it? No, that's not how you do it. It's fine. I'm gonna just keep it like this. So I can change this color scheme. Does this look better? I'm not sure actually. Nah. What do I change it to? This looks pretty cool. It looks alright. Anyways. What am I missing here? Seriously? Oh, maybe this is why it's not working? Hmm. I don't know that already. Okay, I'm not hearing this song like 3 times now. Actually, I can't even play these songs. I feel. Let me just play like this. Am I still live? How long have I been live for? I don't feel like I've done much, to be honest. I haven't figured out anything. At 16. I can think of is it's already long here, so let's okay. Well, let's get back to work. Okay, why is this not working? I mean, this doesn't even make any sense. This is 33,538. That's just straight up wrong. So why is that? I guess we can start about it. So now let's print this data. What the hell is this data? Why? Where did this data come from? print this. So this is just wrong, straight up. Like I'm reading the data wrong. That's basically the problem here. So let's run again. Yes. Let's run this again and let's go. Okay. So now we have our now we're at our the add AI. So in this thing, I'm somehow reading this instruction wrong. Just guaranteed. If I go next here and print this display, so there should be nothing. It's nothing. Oh, I haven't executed it. Yeah, let's print display. There's there's nothing. Okay, there is no displacement because as you can see, the opcode or the instruction is supposed to be add si to 2 or add 2 to si and put it in si. There is no displacement. So as far as that goes, it's correct. And our temp.opcode, sorry again, keep forgetting the opcode is also correct. That's 100,000. That's fine. What about our temp.sign? That's 1. That's I don't even know what that is, but okay. And then what about our print temp dot mod? Our mod is 1 1, which is what doesn't make any sense to me because if it's 1 1, that means it's in register mode, quote unquote, which means it's well, I guess that makes sense, sort of. Let me see this. Okay. Opcode 00 means memory mode, no displacement. Opcode 01 means memory mode, 8-bit displacement follows. Opcode 10 means register mode, no displacement. Okay, so I guess 1 1 makes sense because we're technically moving an immediate value to register. There's no memory involved in this. So yes, okay, fine, that makes sense, I guess. Okay, that makes sense. Then we have this little. Okay, now our temp dot register should be 0. That is, it is 0. Print temp dot rm. Temp dot rm. That's 110. Is that correct? What is rm supposed to be? RM110 is SI if W is 1. So what is W? Print temp dot word size. Okay, so everything. Okay, so data is correct. Sorry, the data is definitely correct. Everything is correct here. Our displacement is correct. What about print temp dot data? Actually, we don't need binary data. So no, oh, low data. Ah, I see. Okay, I see the problem. We only take the data if the signed value is set. Or sorry, if the signed value is not set and the W bit is set. Okay. Is our sign is set is set or not set? Print temp dot sign. It's set, which means you don't take the data. I see the issue. I see it. So right here, where's the data? Where are we taking data? Decode data. We call this wasn't this something like if the word size is something or something like that? I swear it was like you only take the second piece of data if the word size works. Have I done something wrong? Ah, okay. Right here. If this and decoded dot sign, if sign is zero, it's not gonna work. If sign is one, so this is supposed to be opposite. So this is something like, sorry, what the? Oh, caps lock. That's why. Okay. Now everything should work. There we go. Come on, come on. What do you think? Okay, okay. This is still wrong. Why is this still wrong? No. Did I say decoder that's assigned to one? It's int. Okay. Yeah, that's correct. We're saying we only take this data if decoded.sign is like zero. If it's zero, that means it's false, which means it's true because I inverted it. And if it's one, that means it's true, which means it's false. I mean, I don't see what the problem is here. Oh, by the way, I just realized something. If there's 100,000, we're not even calling that little function because we don't even check for data. Wait, no. Wait, how do we do that for immediate to register memory thingy? This has some data, right? 110001. Decoded outcode. Sorry, why are we doing this here? That is supposed to be done only if. Is this even correct? Sorry, this is dumb. I thought we're doing this in the decode additional section. That's where we do our little high data, low data. Wait, what am I doing? I'm so confused. This is so confusing. Yeah. This is it's only if decoded and decoded dot sign is this we do that. It should work, but I need to fix something. See, now it works. Kind of. It doesn't exactly work, but it kind of works. At least the registers are fixed. They're coming in. BP, CX, BX. I mean, really, most of it started working. Okay. So most of it kind of works. Now I just kind of need to figure out what the heck I'm doing in these parts. Um, in our decode instruction, we are only supposed to take in 2 byte increments. There should be no, there should be none of this unless there's a special reason to do so, which is going to be if we have a situation like the 1001 1011 move instruction where we have 1 byte of data which we have to decode. So actually speaking, get rid of this, put this here, get rid of this, actually get rid of this. Sorry. Okay, so if it's 0001, let's go to that. I completely forgot about that. Okay, yeah. If it's 001, okay. Perfect. So now this should work. And if there's any additional data, it's going to do it over here. I think that makes a lot of sense, actually. Okay. Okay, now we need to figure out why these are not being taken as data and they're kind of used as registers or whatever. So let's do that. Um, okay, let's go to the debugger and exit this. Yes, like this. Here, let's run connect. Okay, so now we are in our thing. I want to do temp print slash temp dot, or actually just temp dot. Oh, oh, actually, yeah, wait, let me go this print temp dot this. This should come out to be, this should come out to be 0. Very nice. Print temp dot opcode. That's correct. Let's go next. Correct. Uh, so that's also correct. Next. Let's do that again. Did that change? It did. 1101. Okay, so now it's printing the correct register. That's good. Print. Let's go to the next one and do this. Print temp dot rn. It's printing 110 for both or sorry, I meant register. Printing 1. We don't have 1. It's going into the wrong loop here. It's not supposed to go into this loop. It's supposed to go for print instructions. It's supposed to go not into this one, not into this one. Actually, well, it is. It's supposed to go into this one. Why is this not going into this? What? It completely. Why is that 0? Okay, now that doesn't actually make any sense. Okay, yeah, it's supposed to go into this loop, but it's not going there because temp.load data is 0. Why is that? That's clearly something wrong with this. Wait, why are we getting the high data? What? How did this change? Isn't this supposed to have low data and then high data? This is not big endian. We're little endian mode. There we go. That fixed it. That was the error. I don't even know how that error came about, but okay. I think now we have a lot of the instructions working. BP22. What? Okay, yeah, right here. 228. BP plus 2, BP plus SI plus 4, BP plus DI plus 6, BX plus SI BX, BP BX, this works. BP, for some reason, this is B X plus 2 CX, yes. BP plus SI plus 4 BH, bp plus di equals 6 di bx. Okay, so I don't know what this add byte word stuff is, so I need to figure that out. Add al bx plus si, add ax bx, add alh, add ax. So some of these instructions are not working. That's cool. Yes. Okay. So some stuff I still need to figure out this byte and word stuff, so I'm gonna figure that out real quick. But before that, I'm gonna go up, copy this stuff. I'm just gonna paste it once, paste it twice. This is all gonna be sub, sub, com, com, com. That's gonna be outputs. There we go. So register to. Yeah, I can just do. Okay. This is 0, 0, 1, 0, 1, 0. Then we have 100,000. Ooh. And then we have 0, 0, 1, 0, 1, 1. Okay, what about com? Here. Oh yeah, com. 0, 0, 1, 1, 1, 0. Okay. 100,000. 1 equals 100. I'm actually just gonna change this to 100,000. And then we have so we have 4 ones. Cool. Deep inside. Am I doing iterative? Seems fine to me. What about F stream? I definitely need vector, I definitely need direction, I definitely need. Okay. This works fine. I think the byte and word have to come later. I'm a little tired. How long have I been doing for? 69 minutes, but that's more than enough. I'm gonna chill out.